So let's take a look at an example of Rolle's theorem, and let's show that either Rolle's theorem does or does not apply to f of x equals sine of x on the interval from 0 to pi. Now we know sine of x is continuous for all x, so the continuity issue is fine, and it's also differentiable for all x. So the conditions for Rolle's theorem so far satisfied. But what I need here is, this is what I'm thinking of as a by the definition. This is b. So I need f of a to equal f of b. Well, sine of 0 is equal to 0, and that's also the same as sine of pi. So all these equal 0, so I know that Rolle's theorem applies. So here's one of the conditions. Another condition, which I said earlier, is that sine of x is in fact continuous for all x. Therefore, clearly it's continuous on 0 to pi. And likewise, sine of x is differentiable for all x. Therefore, it's definitely differentiable on the open interval, 0 to pi. So everything here that's needed for Rolle's theorem works. Now, like I said, this is an existence theorem. It doesn't tell you what that value is, but I'm guaranteed that it's there someplace. So how would you find it? Well, find f prime of x. The first derivative of sine is cosine. If I take cosine of x, set it equal to 0, and I'm going to limit myself to 0 to pi. Well, when is cosine of x equals 0 on 0 to pi? That only happens once, and that happens when x is equal to pi over 2. So this is where this happens. And we found that by using old techniques. Rolle's theorem just confirmed to begin with that it would exist. So again, it's an existence theorem. It said it's there someplace. I'm not going to tell you how many. I'm not going to tell you how to find it. But you can use other techniques to actually find it.